Okay, let's continue. I'm super excited to have Holden here again this year, and she's going to talk about accelerating big data beyond the JVM.
Awesome. Thank you for having me back. I don't know if last year's talk was good or there just weren't too many people. Regardless, I hope you're interested in going beyond the JVM. So I'm Holden. My preferred pronouns are she or her. It's tattooed on my wrist in case you forget. I am a developer advocate at Google. They pay me money and therefore are excellent people. If you consider buying things from them, please do. I am on the Apache Spark PMC. This colors my views of the world, but not that much because it also makes me hate Spark because I work on it. Previously, I worked at IBM with Nick. He still has not merged my pull requests. I'm very upset with him, but I am planning to track him down before his flight, and a bunch of other companies as well. I'm a co-author of 2 Spark books. I think you can buy them from the O'Reilly booth upstairs if you want. One Spark book is about 1/4 of a cup of coffee in San Francisco, so you can help keep me from having to do enterprise support contracts, although I already worked at IBM. You can follow me on Twitter. There's not a lot going on. It's a lot of pictures of Boo, who, while adorable, does not do a lot of programming. She's great. In addition to who I am professionally, I'm trans, queer, Canadian on a work visa in America, which is just really fun right now, and part of the leather community. And this maybe doesn't seem super important, but I think it's just nice to remember that we all come from different places, and we should work together. There's no secret Canadian garbage collector or anything that we're hiding from you. We all have out-of-memory exceptions. Our lives are all terrible. But if we work together, our lives can be terrible together. And I think I just saw someone having the Spark book with the bird on it. Yay! Okay, so thank you for the 1/4 of a cup of coffee. I really appreciate it. So I'm hoping you're nice people. If you don't like pictures of cats, this is not the talk for you. There are 2 exits. But you can also just work on your computer. It's fine. It's possible that how many people are Spark users? Oh, that's a lot of people. That's awesome. Okay. Oh, and Nick, merge my PR. How many people are Flink users? There is some overlap, but not as much as I was hoping. Now for the real long shot, are there any Apache Beam users in the house? Wow. We should talk afterwards. I'm really excited to see that there's some Apache Beam users here. That's great. Is there anyone who doesn't use any of those systems? Cool. What do you do for big data? Or is this more just like whatever, there's a talk sort of situation? Okay, it's the whatever, there's a talk situation. That's fine. That's all right. I will try and convert you to one of the big data systems which indirectly pays me money. It's pretty much all of them at this point. I'm very much hedging my bets. So how many people know some Python? Oh, thank God, my people. How many people are R programmers? I am really sorry. And how many people are just fed up with the JVM? There are only like 6 people. That is weird. Okay, the slide has clearly gone on for too long. Okay, well, you're in the big data room, so whatever. This is for big data. For those of you that don't have a big data system, please pick one, preferably one that pays me money. Most big data systems are written in the JVM. Not all of them. There's Dask and other exciting things like this, which have decided that the path to happiness does not involve Oracle. And I respect that choice as well. But thankfully, they still have to interact with the rest of us, so they still feel our pain. So there is no escaping the wonders of the JVM. We're going to look at how PySpark works. We're going to look at how other similar systems work as well. We're going to talk about why this kind of sucks. And we're going to also talk about why things are finally changing. And how the experience for Python users is finally actually getting better. And they'll try and get you to buy my book many times over. The TLDR is we've made some bad choices, but we're finally fixing them because investors noticed. And yeah, moving along. Okay, so what is the state of non-JVM big data? It's a wonderful mixture of pickling, strings, JSON, and XML, often all inside of the same project. Yay! I love 3 different serialization libraries involved in calling a single function. No one is excited. Okay, the other one is, sometimes people look at that and they go, you know what? That doesn't sound slow enough. I'm going to use Unix pipes. Or alternatively, this sounds too portable. I'm going to use Unix pipes. And that's often used, not always. Some other people look at this and say, maybe I'll use sockets to connect Python and Java. And alternatively, other people look at this and they go, you are all just out of your minds. I'm just going to rewrite this in Python. How hard could it be to rewrite all of Spark in Python? I'm sure there wasn't a lot of development work that went into that. I'll just read a paper over the weekend. And that's how we got Dask. And then they did a lot of work. And it got a lot better. But, it's that classic problem of, well, what does your field do? I bet I could do that with a Perl script. But Perl is no longer cool, so we use Python. So, PySpark. Are there PySpark users in the house? Yay! And I'm sorry. So PySpark has the same general technique for how most of the other non-JVM languages work with Spark. It turns out most of the other big data systems looked at Spark and went, that was interesting, and took different directions to integrate languages, but fundamentally made pretty much the same trade-offs. And it has some serious performance issues that we're finally going to fix, maybe. Okay, and because this is a big data talk, I had to put in a word count example. It's a licensing requirement. I'm from California, and we're very serious about not getting our licenses revoked out there. So this is the word count example. And we can just see, we have these nice little Lambda expressions. There are friends. We can tokenize things. I can add numbers together. It's very exciting. Anyways, we'll move along. So how does this monstrosity work? We take pickles. I guess we couldn't figure out an image to represent JSON, so we just wrote JSON. We could have probably just had a programmer crying. I don't know. Okay, yeah. So how does Spark do this? Spark uses Py4j on the driver side. And the driver is sort of it's the thing which is sort of coordinating a lot of the work. And it's where your Python program, the part of it that you see runs. And it's the part which throws exceptions, which uses JSON and magic. And then we use pipes because that's a great idea. We also don't use the standard pickling library because that was far too, it worked like that. And then we decided that we were just going to write our own pickling library. But we stole it from another project, copied it in, and called it cloudpickle.py. Someone copied it out and has been fixing bugs ever since that we have been backporting about a year after they fixed them. And yeah, okay. And there's a way around this. We can use Spark SQL, but then we lose our Lambda functions, and it makes us sad. So this architecture diagram, in addition to showing that I do not work with designers, shows Python, talks to Java, and then Java is the one who does a lot of coordinating, and then this sadness happens. In Flink, the same thing happens, except replace all of the things with other things, and instead of sockets, use mmap. I'm pretty sure this is how it works. I looked at the code this morning. And so how does this impact PySpark? I mean, I'm pretty sure it's an mmap file. There were a lot of bugs about an mmap file behaving poorly, and I was like, that is probably a core piece of your tech. So we have this really expensive double serialization that's happening. Python worker startup takes a little bit of extra time, and the error messages don't make any sense. Excitingly, we're not going to solve this one. We're going to make this one worse, but we're going to try and solve this one. So that's okay. So Spark data frames, they're nice, but they're not perfect. We're just going to sort of skim over them, but we can see that when we take out the serialization cost, the blue is good PySpark code, and then the yellow, the hideous yellow, is the PySpark data frame code, where we don't actually do any of our work in Python. And so we can see that this is a pretty big difference. This Python overhead is huge. And so if I can reduce the amount of overhead, I'm going to see some pretty big improvements. And so we're gonna take a look at this problem, and we found out we were spending most of our time copying data from Java into Python and back. And then it turned out we were actually spending a lot of time serializing and deserializing the data. And when I looked inside of all of the other open source projects, everyone had their own custom serializers, because apparently that is a great way to add value in open source, is adding a new serializer. And so, yeah, so by the future, actually, in theory, we're voting on the release right now, so this should probably be 1 month to eternity. But I'm optimistic that we'll actually get a release out in February, probably, but like, it's okay. I live in California. It'll be hard for you to track me down. And so this code exists. If you want to try it, you just need to check out this branch 2.3 from Spark. And then we get Arrow. How many people have heard about Apache Arrow? 5 people? That's low. Okay, so Apache Arrow is what happens when your cat decides they like catnip and serialization frameworks. Right, so Apache Arrow gives us this really nice performance graph. Ooh, big numbers are bad unless I'm selling you compute time, in which case continue to use slow serializers. And small numbers are better. But Apache Arrow is really awesome, and it gives us a common format that both the JVM and Python can understand, so I don't have to write custom serializers, and I can start to use shared memory buffers intelligently, as opposed to putting strings in shared memory buffers and being sad about my life choices. And so I have this graph which shows that Apache Arrow can talk to a shit ton of things. But from the big data point of view, I mostly care about that it can talk to Java. It can also directly read in Parquet files. And I can put Apache Arrow records in TensorFlow, R, Python, and even feed it into CUDA if I decide that I want to give NVIDIA all of my money, which is fine. NVIDIA makes great products too. And so this is really nice because this interchange has historically been really, really expensive. And you can see that this, I mean, when we're adding the number 1, we're doing pretty much no work. And we go from 3 seconds to 0.9 seconds. And so that's really awesome. Actually, this might be hours. I'm not super sure. Oh, no, it says seconds. Yeah, OK. So adding the number 1, pretty fast. And this is not obviously on one record. If it took us 3 seconds to add the number 1 to one record, we'd be very sad people. Yeah, OK. But so this is awesome, and it means now that I can start to use the cool tools that the Python kids have been using, because I live in San Francisco, and if I don't put TensorFlow into my product, I am not raising another round of venture capital, and then I cannot afford to go to Blue Bottle anymore. And so this is pretty much a mission-critical thing for people like me. So how do we access this? In Python, and here we're going to add not the number 1, but we're going to add 2 arbitrary numbers together. We go from writing this really ugly UDF into writing this other really ugly UDF, but we say pandas UDF. Now we say pandas UDF rather than arrow UDF because this is the way that we expose arrow into Python is as a pandas data frame because pandas data frames are nice and happy. And so yeah, that's great. OK, what do the other systems do? Don't worry, they all suck. Hadoop streaming is not streaming, despite its name. It uses Unix pipes and sadness. Kafka re-implements everything, so they take sort of the Dask approach to life. And that's great unless you want to use new features. So features from 2 years ago work great. Dask re-implements everything, has multiple backends. It's pretty awesome. The only problem has been historically it's difficult to get data into Dask. But thankfully, we can now use Arrow to get data into Dask from Parquet data. And so that's pretty awesome. Beam, yeah, we don't do things beyond the JVM very well right now. But we have a bunch of Jira issues, which you are more than welcome to join me on. Yay! Does anyone want to do my job for free? Alternatively, wait 3 to 6 months and someone else will fix it for you. There's a bunch of references. I really don't have a lot of time to go into the C++ code that is scary and powers Arrow, but you can go check it out. There's some interesting blog posts. If you want to verify the benchmark slides that I showed you, you can go get them and run them on your own data. And that's pretty much it. The most important slide is this one. You can buy High Performance Spark. It covers none of the things I talked about today, but it is an excellent book. And if you buy it online, you can receive it in a nice box that your cat will love. And so that's pretty much it. I might do office hours at 6, but honestly, I think I'm just going to go get chocolate. So let's pretend the slide didn't happen. I don't know if I have time for one question or if I use that up with the VGA adapter.
You have lots of time.
Okay, cool. Sorry, I saw the 5-minute slide, and I wanted to make sure there were time for people to heckle me, just in case anyone had questions about how Arrow works or Spark.
We have plenty of time for questions.
Or if anyone wants to buy several copies of my book, I can go back to the website. Oh wait, I didn't put the website name on it. Oh, just High Performance Spark. This is the keyword to type in. I notice very few laptops open right now. Very few laptops. That's unfortunate. Okay.
There's a question.
Yay, questions!
Come in.
I'm curious a bit about about Dask. Just
Yay.
I've heard it from our users. I'm not super familiar with it, but you said maybe in the ecosystem it's not as up to date. Is that what you would say?
Right. So I think Dask is a really interesting system, and its main challenge is that it eschews most of the existing ecosystem. So it's very Python focused, and it doesn't necessarily do a great job of integrating with other data sources. So if you've got existing big data, you might find it painful to integrate with your other tools. On the other hand, if you're sort of starting from a small data shop, which has then realized, now you have customers and you have big data, then Dask can be pretty cool. It also doesn't have a great machine learning story right now, although some people might be working on that, hypothetically speaking. And honestly, it does a really nice thing. Dask data frames actually look and behave like Pandas data frames to a much larger degree than any of the other distributed systems. All of the other distributed systems' approach to data frames is really great. Yeah, really delightful and unique. Okay, right, there's a camera, and I like my job. Okay. Yay, a second question. Oh, yeah, and there's a coworker in the back row. It's a good thing I didn't say what I was going to say about data frames.
So if I understood correctly, Arrow wants to provide the serialization format across Java, Python, R.
Yeah.
So why not something like protobufs or thrift? What's the difference?
I mean, this is a great question. And so if you look at Arrow, it actually does use flat buffers in some places and stuff like this. Arrow is more than just a serialization format. The part of it that I care about is primarily the serialization format, but there's also operations that are defined on the serialized data as well, which is really nice and convenient. Lots of fancy numerical stuff. I mean, honestly, so we use protobufs a lot in Beam, and there's nothing wrong with those. Arrow is just much more focused on making things that look like data frames for serialization between these different systems and providing the tools you need to build nice data frame-like interfaces on top of it. So we can have some of this shared code between R and Python. Most of the times we actually end up calling Fortran code that was written in the 70s, but now we can share the Fortran code that we've hopefully rewritten into C++ to switch how much I want to gouge my eye out with a rusty spoon to be less so. Yeah, if you were to go and make your own, you could go ahead and use protobufs. But everyone else is using this one, so maybe we should all be friends together. Because if we all use the same thing, then I can just steal your users or whatever it is. We can collaborate.
Yeah, that's
and
why
be
I'm
friends.
asking this.
Well, I mean, I think fundamentally a large part of it is probably social in that the person who started the Apache Arrow project is also the same person who started the Pandas project. And so it's like, oh yeah, this person knows what they're doing. And so it's a lot easier to gain adoption when you have a good reputation for making good design decisions.
So apart from a serialization format, is also focused on data frames.
It's focused on data frame-like data.
Yeah.
So yeah, if you want to serialize a random number generator, Arrow is probably not the format for you. So you wouldn't use Arrow to serialize your Lambda functions either, right? This is very much just serializing your data, not your functions. And we pretend there's a difference because otherwise I have to go and relearn scheme. Okay, cool. I think that's it. If anyone wants to come find me or Boo, I'll be around until I find coffee. Thank you.